Learning with Ike. Welcome once again. If you haven't subscribed to this channel yet, please do so. Tap on the bell icon so you get a notification anytime there's an upload. We are looking at indices and logarithms for this video session. What are our expectations? So by the end of this session, we shall take a look at the index notation. We'll start looking at the laws of indices and then the properties of indices too as well. If you still have enough time, then we shall start looking at exponential equations. So let's quickly begin. Alright, so index notation. Index notation. Okay, so the index notation, or in other words, the index form is the simplest way to write numbers. For example, 5 exponent 3 is written in an index form, where the 5 there, alright, represent the b's. The 5 is called the b's, and the 3, alright, is called the index. Okay, so we can have 3 exponent 5 or 7. Okay, so this is also presented in an index form, and over here the 3 is the b's, and then the 7 is what? The index. Okay, the index tells the number of times you have to multiply the b's together. Okay, the index helps us, all right, to identify the number of times we have to multiply the b's together. And so for this very one like this, for 5 exponent 3, it means 5 should be multiplied. That's the b's, all right. So the b's should be multiplied by itself 3 good times. That of the 3 too. So 3 exponent 7. It means we have to multiply the b's, all right, to itself 7 times. That's 3, okay. So 3 is to be multiplied to itself 7 times. So 4, 5, 6, and then 7. Okay, and so on. So you realize that the other version of the index form, okay, is a little bit bulky, and that is why we like representing them, okay, in index form. So it explains what we just said earlier. Index notation or index form, it's one of the simplest way to put numbers, all right. Okay, so in general, if we have a number, all right, or a term raised to a power of 3, okay, what this means is a should be multiplied, the b's, okay, should be multiplied to itself 3 good times. Okay, how many 3 good times? So how many occurrences here? So we have 3 occurrences or 3 factors here. Okay, that is also to say, if you have a to the power of n, all right, then it means a should be multiplied to itself n number of times, all right. So a times a times a, and so on, all right, and so on. Okay, so that is how many occurrences? So for n factors. So for n factors, and so if the index, okay, it's 2, then meaning you have to multiply a to itself 2 times. Okay. Now the index, okay, for example, here the index is 7, here the index is 3, here the index is n, okay. The index can also be called power or exponent. So just as you can say 3 index 7, you can as well say 3 to the power of what? 7, or 3 exponent 7. Good. Now let's take note of this last information. The index can either be positive or it can also be what? Negative. You should take note of that. So the index can be positive, it can be negative. It can as well be a fraction. Okay, so well, with the following examples, you can clearly see that the index is all the indices are in positive forms, okay? But we can have it this way: 10 exponent -1, all right? So you should expect the index to be -2 as well. When you see that, it does not deviate from the rubrics, okay? And then you can have 14 to the power of -7. You can as well have 2 to the power 1/2, okay? So the index can be positive, negative, or a fraction, all right? That is it. So let's try putting what we've studied into practice, okay? So let's take a look at some illustrative examples, right? Some illustrative examples. All right, so illustrative examples. So the preamble is write the following. Write the following in the index form. So you have, so for the first part we have 4 times 4 times 4 times 4 times 4 times 4. All right, the next one. We have 7 times 7 times 11 times 11 times 11 times 11. So we have to put all these in index form. The next one. 10 times 10 times 10 times 10 times 10. How many are they? All right, so I think it's in time. And then the last one, I guess. So no, not the last, but the last but one. Right, so 5.5 times that times that times that. All right, how many is that? So all right, so I think there are more to be written. So 2, 4, 6, 2, 4, 6. All right, then I think one more. Then the last one, we have 1 over 10 times 10 times 10 times 10 times 10 times 10 times 10. Okay, so 2, 4, 6. All right. Okay, so how do we handle the following? So we have to write them in index form. Okay, you have to write them in index form. solution. So for the first one, A. So over here, you would write, because the 4 is common throughout, alright? You just write one of that, and then you count the number of occurrences. So 1, 2, 3, 4, 5, 6. So that goes to the index side, okay? So that becomes 4 exponent 6, okay? Right, so 4 times 4 times 4 times 4 times 4 times 4, right? It gives us 4 to the power of what? 6. So that is it. Let's take a look at the next question. So it's 7 times 7 times 11 times 11 times 11 times 11. So we have two different numbers over here occurring many times. Okay, so we have 7 here, and then we have that of 11. So you pick 7. Since it's 2, you pick 1, alright? If it's 2 or more, you pick 1, either of me. Then you count the number of occurrences, then you put that value at the top. So you have 7 to the power of 2, multiplying. So how many times is, do we see 11? So times 11 to the power of what? 1, 2, 3, 4. So 11 is occurring 4 times. So that is it. Let's move on. So the C. So we have 10. So for this very one, yes. So how do we represent that in index form? So you just, since 10 is occurring many times, you just pick 1, and then you count the number of occurrences, which is 1, 2, 3, 4, and 5. So 5 comes at the index side. Okay, so I said earlier on that the index indicates, all right, the number of times you have to multiply the b's together. Okay, so in other words, if you know the number of occurrences, then you can put that at the power side or the exponent side. Okay, all right. So we go to the D side of it. So you have 5.5 times 5.5 times 5.5 times 5.5 times 5.5 times 5.5, then times 5.5. All right. So yes, how do we write this in index form? So you just have 5.5 since it's common all through, and then if you count, you realize that it's 7 in number. Let's go. 1, 2, 3, 4, 5, 6, 7. So 7 comes at the top, right? So the comprehensive form is what? 5.5 exponent 7. Okay. All right, let's try the last one. So we have 1 over 10 times 10. So we have 2, 4, 6, 8. So 2, 4, 6, and then 1, 8. 2, 4, 6, 8. All right. So what's the value? So over here, well, 1 stands on its own, so you maintain that. Okay. And then over here, you would have 10. All right. How many times do you see 10 occurring? So we have 2, 4, 6, 8. So 1 out of what? 10 exponent 8, all right, or 1 on 10 exponent 8, all right. We're just beginning, so I'll put an asterisk here. When we start with the laws, all right, when we start with the laws and begin the properties, we'll realize that this is not the end. We can continue by writing it in a different form to obey the properties, all right? So for now, if you leave this one, I'm going to mark you right. But when we go on, you would have to put it in the simplified form, okay? So that is it. When we go on, you will discover that this can be rewritten as 10 exponent negative 8, right? I don't need you to bother yourself so much here, all right? Just understand to this point. When we go on, you get it better, okay? All right, so turn it off. Alright, so we're kickstarting by starting with the laws. The laws of indices. Okay. Oh, it's still cockeyed. Sorry, I want to make it better. Good. So, laws. So that's what we're looking at now. Laws of indices. Okay, so thus far, we've looked at the index notation. Okay? And we picked an example like this, and now we studied that when it's in this form, the number below is called a base, and the number at the top is called what? The index. Okay. Now let me add this. So when it is in plural, that is when we use the word indices. All right. So indices is in what? Plural form. All right. So yes. So now let's start the laws of indices. So now all numbers written in indices obeys the following laws we're going to state on the board. All right. Any number written in index form obeys these rules. Good. So let's start with law 1. Law 1, or in other words, the first law, also called the product law, all right, goes this way. So the first law states that when you have a term with a power, multiplying the same term with a power, all right? Now the power can be the same or different. What you should be looking out for is the similarities in the bases. Are the bases the same? If so, then pick one of the bases, all right? And then since they are multiplying, just add the powers. Okay, now you realize that as I was writing, I said when you have a term, I use the word term, all right? When you have a term with a power, all right? If you followed my first lecture under algebraic expression, you remember that we said a term consists of numbers. We said a term may consist of what? Numbers, letters, or powers of what? Letters. Sometimes it can be a combination of everything. Okay, so you can have 5, okay, exponent 2 multiplying 5 exponent 1. Okay, so over here, well, you have 2 terms multiplying each other. There is the type of term containing just a number, all right, containing just a number. So it's a term multiplying each other. The bases are the same. So what do? So you pick one of the term, that's the base, and then since they are multiplying, you add the powers. So at the end of the day, you would have 5 exponent 3 as an answer. Okay. Good. A term can be letters, okay? For example, so you can have z exponent minus 3 times z exponent 4. Yes, so what is it? So this is 2 terms multiplying each other, and then it happens that they share the same base. All right, so then the first law comes in. What do? Just pick one of the bases they are all bearing, okay, and then since they are multiplying, you remember to add the powers. So you would have minus 3 plus 4. Now you have z index, so you pick your calculators and punch minus 3 plus 4. So when you do that, you realize that the answer is 1. Are you with me? Now, any value raised to a power of 1 is the value itself. Okay, so you can write it as z. So we're still explaining the first law. Okay, I said when you have a term with an index multiplying the same term with the same index or perhaps a different index, what you should look out for, all right, should be similarities in the base. Are the bases the same? Are they multiplying? Then you can apply the concept. All right. And then what next again? So I said the term may consist of a number, a letter. Let's look at powers of letters, okay? So you can have a squared, b squared, all right, all to the power of 5, okay, multiplying, open parenthesis, a squared, b squared with a power of, say, 2, okay? So what is happening? So realize that for this very question, the term here is what? A combination of what? Powers of letters, all right? It's a combination of what? Powers of letters. The term over here you see with what? Combination of what? Powers of letters. Okay. So what did we say? The term here is the same as the term here, all right? And then they are multiplying. So the first law comes in, all right? So you pick, since the bases, all right, the bases are the same. So a squared, b squared. Over here, a squared, b squared is representing the base, all right? Because the power is what lies outside parentheses, okay? Since the bases are the same, you just add the powers. And they are multiplying, you add the powers, okay? So you would have a squared, b squared in parentheses, then exponent 5 plus 2. What is it? So a squared, b squared, okay? Exponent 5 plus 2 is what? 7. Yeah, avoid crossing your 7, okay? Yeah, I prefer it being this way. I know me. Now going forward, you realize that this is also not the end. Right now, what I need you to know is powers of letters, all right, can be part of a term, all right. So you should expect one of your terms being this way. Are you with me? Good. Now going forward, So I've been putting an asterisk there, so maybe we can make reference back again. So going forward, realize that at a point like this, law 3, all right, you have a squared multiplying 7, and then b squared multiplying that 7 outside. The 7 should affect each thing inside the bracket. So you would have a 7 to 14, b 14, all right, and that is it. I don't really want you to bother yourself to this extent. When you get to the asterisk, just have your peace, okay? When we go to the power law, you would understand better. But all right, so let's take a look at some few illustrative examples. So let's do it here. Okay. So we have I 2 exponent 2 times 2 exponent 3. I 5 exponent 1 times 5 exponent 2. X exponent 2 times x exponent 3. 2x exponent 4, y exponent minus 3, multiplying 4, x exponent minus 2, y exponent 6. 12a squared times 4a exponent 11 times a. Okay. Before I continue, let's come here once again. So I told you a term can be what? Just numbers, which we've done that, or letters, or powers of letters. I also said it can be a combination of all the three. You should expect that. Okay, so let's come to example IV. So realize that the term here, this is a term, alright? It's a combination of what? Numbers, letters, either be numbers and powers of letters. Even here, we use just the two of them, alright? So you have numbers and what? Powers of letters. Okay, so a thing like this, how would we solve that? Yeah, so we will apply the same concept when we get there. So solution. So I. So for 2 exponent 2 times 2 exponent 3, I believe this will be very smooth for you in solving. So you would have 2 exponent. So you see the bases are the same and they are multiplying. So just pick one. Then you add the powers. So that would be 2 plus 3, making what? 2 exponent 5. If you don't understand at a certain point, please play back continuously until you get that. Okay? I. So we are applying the same concept. 5 exponent 1 times 5 exponent 2. What's the value, please? So you realize also that the bases are the same. And so you pick one of them, okay? And then you add the powers. So it's going to be 5 exponent 1 plus 2. Okay? I. Did we really finish? So that's going to be 5 exponent what? 3. Now please take note that you can have the question this way. Whenever you have a number standing on its own, okay, it's raised to an index of 1. Take note of that. So any number, any whole number, alright, standing on its own, for example 10, is always raised to a power of 1. Okay, so remember to capture that when you carry on your addition. Okay, what's the next question? I. So you have x squared times x exponent 3. So you're going to have x, then because the bases are the same, I picked one, and then since they are multiplying, you add the powers. So what are we having? 2 plus 3, making x exponent 5. Okay. Ivan. So you have 2x exponent 4, y exponent minus 3. Alright? And then 4x exponent minus 2, y exponent 6. That was the question. Yeah, so something like this. This is one of the terms containing numbers and then powers of letters. Alright? So what do we do? Now there are a few things you need to know here. The bracket means they are multiplying. That's one. And then number 2, the numbers being joined together, it means they are multiplying each other. Okay? Alright. So this thing you see here actually means 2 times x exponent 4 times y exponent minus 3. And the bracket means they are multiplying. So times 4 times x exponent minus 2 times y exponent 6. This is what you need to know. So what next? So the numbers will multiply themselves. So 4 will multiply the 2, making 8. And then, now you realize that there are some variables that are the same. Okay? Variables are letters that are used to represent numbers. That is what we said when we're discussing algebraic expression, alright? So there are variables that are the same. You can see x exponent 4 and then x exponent negative 2. They are the same, and everything you see is they are multiplying. And so you pick one of them, and then with the powers you add them. So I will have x exponent 4 plus, so you add them, plus minus what? 2. 4 plus minus 2. Okay? Then not only that, we are left with the variable y. Right? So y, since they are 2, you pick one, and then the powers, since they are multiplying, alright, the terms are multiplying, the rule says that you should add the powers. Okay? So you would have minus 3 plus 6. I had to put the minus 2 in brackets so that they don't look so confusing. At the end of the day, you have 8x exponent. So please check it out. 4 plus, check it from your calculator. 4 plus minus 2. What are you having? 4 plus minus 2. Just get a calculator and then put these expression inside. Alright? So at the end of the day, you would have that's 2 as your result. Don't worry, at the right time, I would discuss this into details. Just use your calculator, alright, for this very video section. Alright. At the right time, I'll discuss integers with you. This lesson is not for that. So then y exponent. So check out minus 3 plus 6. If you check from your calculator, you get 3 as a result. Are we together? So that is it. That is it. So let's move on. Let's move on. So I think there is one more example up there. Can you pause the video and try that before I even put down the solution? Okay. So, what did you get as your result after pausing? Okay, so let's see. Are you having, so the question was this way. Times 4a exponent 11 times a. So over here, the numbers are going to multiply themselves as usual. So 12 times 4 will give us what? 48. The numbers available is 12 and 4. Okay? And then now the letters is A running all through. So I'll pick one. And then since it's multiplying, everything is about multiplication, I would add the powers. The rule says if the bases are the same, here is A all through, they are the same, and they are multiplying, then add the powers, okay? So it's going to be 2 plus what? 11 plus 1. Mind you, I said that any whole number is raised to an index of 1. You know index, isn't it? Same as power. So you would have 48 A exponent. 11 plus 2 is what? 13 plus 1, 14. That is it. Can we move on? Okay, so if you don't understand anything, like I said earlier on, keep on playing the video repeatedly until you get that. Roger that. So let's move to the second law of indices. Okay, so we're taking a look at the second law of indices. Okay, second law of indices. Okay, so it's also called the quotient law. What is it about? Okay, so it goes this way. So when you have a term, okay, with a power, this time around, dividing the same term, I've explained my definition for terms. Dividing the same term with a power. The power can be the same or different. Okay? Just pick the common base they are sharing, okay? And then since they are dividing, the rule says that you should subtract the powers. You can make this in this form, alright? So A exponent m divided by A exponent n can also be rewritten this way. So A exponent m over A exponent n, alright, is the same thing. It's the same thing. It's the same as A exponent m divided by A exponent n. So what is the result? So the same thing, you pick the common base and then you subtract the powers. Okay, so that is it. So let's take a look at some following illustrative examples. I will not talk much about this. I'll not talk much about this because we've already done that. Okay, so that is it. So illustrative examples. All right. So let's take a look at this. 2 exponent 4 divided by 2 exponent 2. 3 exponent 6 divided by 3 exponent 3. X exponent 5 divided by x exponent 2. 21 x exponent 12 divided by 14 x exponent 3. 24b 19b divided by 8b6 times 2b5. Okay, so we have these examples on the board for us, so let's try them together. All right, so solution. Let's do it here. Solution. So the I. So what's the question? So we have 2 exponent 4 divided by 2 exponent 2. So what's the value? So we have 2 exponents. So the bases are the same and they are dividing, all right? So you pick 1, then you subtract, because they are divided. The law says the quotient. Quotient is about division. The quotient law says that you subtract the powers. So you would have 4 minus 2. So at the end of the day, you would have 2 exponent 2 as a result. Okay, let's check the second part of it. So I'm having 3 exponent 6 divided by 3 exponent 3. So with this very 1, 2, you would have the bases are the same and they are divided. So you apply the same concept. You pick the common base they are sharing, then you subtract the powers. That's going to be 6 minus 3. So what are you getting? So that will be 3 exponent what? 3. Alright? So that is it. Let's check the next one. So we have x exponent 5 all over x exponent 2. So what's the result? So you have, so I told you this can be rewritten as 3 exponent 6 divided, 3 exponent 6 over 3 exponent 3. So you shouldn't be surprised. So something like this, you should take note that it can be rewritten as this way. And this you can clearly see. So what is the next step to do? The bases are the same and they are divided. So you just take the common base they are sharing and then you subtract the power. So making 5 minus 2. What's the answer? So we having x exponent 3 at the end of the day. I believe you are following. Okay, let's look at the IV. 21 x exponent 12 divided by 14 x exponent 3. So what are we getting? So we have, so they are dividing, okay? So now, over here, we will divide the numbers, okay? We'll divide the numbers. So we'll have 21 on 14. We should know the results. Then for the variables, you see they are the same, so we'll pick 1. Then we subtract the power, so that will be 12 minus what? 3. Now let's look at the simplification for this one. What number can be divisible? So we have 3. 3 can go into, so let's check it out. 21 on 14. 3 will go into this one. 3, 7, alright, 21, isn't it? No, 3 cannot go through these numbers, alright? 3 cannot get into 14. So what do? Should we use 7? Yes. So 7 will go into 21, 7, 3, 21, alright? And then 7, 2, 14. We're looking for a number that can get through both the top and that of the down, the numerator and the denominator. I'm not having a calculator with me. You have. So you should be able to hold this on your calculator. It will give you 3 over 2 at the end of the day. Okay? But if you want to understand the logical reasoning behind that, you pick a number that can divide through 21. Either me and can also divide through 14. So realize I picked 3. But 3 couldn't get into 14. That's why I use 7. 7 can get into 21 3 times and can get into 14 2 times. So you would have 3 over 2, since it cannot be reduced further. Alright, then x exponent 12 minus 3 is going to give us what? 9. Yes, 9. So that is it. Let's check the next one. What is the next question? Alright. Oh, we're picking it from here. That's smart. Alright. So we through with this one. Let's take a look at this. It looks a bit complex. It requires that we use the previous knowledge acquired on the product law or the law 1, all right, in simplifying this completely. Not only law 1, we will apply the second law we studied right now to this 2 as well. Let's take a look. All right. So that's the question. So over here, let's pay rapt attention. So we'll solve them one after the other. We'll take 24 first. Okay? 24. Now, you realize that the letters attached are the same. And as I stated earlier, when you have two numbers joined like this, it means you are multiplying. Alright, they are multiplying. And what does the rule say? You have two letters, two things, two terms multiplying. A term can be a number or a letter or powers or letters or a combination of all. Alright. So you have two terms multiplying and the bases are the same. So you pick one of the term, then the powers you add them. So you would have 19 plus what? Your guess is as good as mine. I told you when a whole number stands on its own, it has an index of 1. Okay. So now divided by, apparently that's the last example for second law. So divided by, so over here you would have 8 multiplying 2. That's 16. And then the B. The B's are the same, and so I picked one. They are multiplying, so I'll add the powers. That will be 6 plus 5. Alright? So at the end of the day, you would have 24 B to the index of 19 plus 1, which is 20, divided by 16 B index. 5 plus 6 is what? 11. We are not done. There is still some step to go. Either way. So, over here, you divide the 24 by the 16. Either 24 by the 16. And when you are done, the letters too, you pick one. They are the same and they are divided. So you pick one and then the powers you subtract. So 20 minus 11. Roger that. So 24 divided by 16. What number will get through? So let's use 8. So 8 will get through this. 8 to 16. 8, 3, 24. You're looking for a number that will get through the two at once. Alright? Not different numbers, but a singular value. Okay? So 8 will help. So over here, let's continue here. So you would have 3 over 2 as a simplification for 24 over 16. Then B index. So you would have 20 minus 11. Yes, 20 minus 11 is what? So that is 9. So that is it. So that is it. That is the value for this whole bulky expression. That's fine. All right. We have exhausted all our examples. So we move straight to the third law of indices. Okay. I'm going to clean that. Okay, so for the sake of those that would be writing, we write in here. So we have third law of indices. All right, so it's also called the power law. The power law. The third law of indices, also called the power law. Okay? All right. So it says that whenever you have a term, okay, with a power, all right, raised to another power again. So if you remember, when we started the lesson, we met something like this. Okay? Yes? So what is that? What is the simplification? So it's all about taking the term and then the powers, just bracket means multiply. So you just multiply the powers, making mn. Okay. Let's try some few examples. There are a lot more to say about this. Alright. We have to apply some few knowledge under algebraic expression. So let me get you some examples. So illustrative example. Illustrative example. So we have I 2 exponent 4 all power 5. What's value? We have 3 exponent 2 all power 3. All to the power of 3. What's the value? You have x exponent 2 to the power of 4. What is the value? IV. We have a squared b 3. Alright. To the index of 2. What is the value? And lastly, we have 2x exponent 4 y exponent 3 to the index of minus 2. What is the value as well? Okay. So solution. So with the first one, I think it will be easier for us to do that. So with 2 exponent 4 power 5, I told you when you have a number with an index raised to another index, okay, just pick the number and multiply the powers. So you're going to have 4 times 5, okay, and this will give you 2 exponent 20. Great. Next, II. So when you have 3 exponent 2 raised to the power 3, can you pause the video and then try that yourself? Alright, so after doing that, what did you get? Let's see if your answer tallies with mine. So you would have 3 exponent 2 times 3. Given 3 exponent 3 plus 3 times 2 is what? 6. All right. I. You have x exponent 2, then exponent 4. What's your value as well? So I guess you would have x exponent 2 times 4, which is x exponent 8. Okay. IV. So you have a exponent 2, b exponent 3, all squared. Okay? Now, when we were doing algebraic expression, we once said that whenever you have 2 terms, so this type of term is powers of letters. Okay? Whenever you have a term in parentheses, parentheses means bracket, okay, raised to an index, the index affects each single thing you see in the bracket. Please, let's run across, okay? So over here, the a squared must be affected with the 2. So, well, obviously, it must multiply if you're following the law. The b Well, apparently it's cube, but it must be affected with the square too. That is the right way, mathematically. And in conclusion, you would have a exponent 4, that's 2 times 2, the result for 2 times 2, and b exponent 6, the result for 3 times 2. So that is it. Can we apply the same concept to the vein? Now, if you listen attentively, there are some few things to observe from the vein. Now, I think we have the chance to rub this off. Okay, so the vein is here. You have 2x exponent 4, y exponent 3, all to the power of minus 2. So what is that? So if you listen attentively, I said the power must affect each single term in the bracket. So 2 will get a share. 2 will be affected. So 2 exponent negative 2. So times, alright, so maybe we should ignore that. Let's move to the x. X will be affected. Already it's raised to the power of 4. When it's being affected, it would have to multiply the minus 2. Y. Y is raised to an index of 3. It will be affected. It must have to what? Multiply the negative 2. So you would have 2 exponent negative 2 here. X exponent negative, the result for 4 times negative 2 is negative 8. Then y, the result for 3 times negative 2 is negative 6. And that is it. So you have 2 index negative 2, x index negative 8, and y index negative 6. Right. The power affects each single term in the bracket. Students, this brings us to the end of this lecture session. Unfortunately, we couldn't start with the properties. So the properties, together with exponential equations in indices, will be discussed in the next video session. Remember to subscribe and stay active on our channel for more. I'm going to leave you with some assignment which covers the few topics we discussed. Please visit our Facebook page, Learning with Ike. I'll leave the questions over there, all right, for you to attend to them, all right? So visit the page and then take the questions, do that, and then submit it to the school's mail, okay? The school's mail is Seekers Remedial College at gmail.com. So after doing the assignment, you can just take clear photos or you type that anyhow you will feel comfortable with, all right, and submit it to the school's mail, seekersremedialcollege at gmail.com, with your name as the subject, okay, with your full name as the subject. I'll be expecting that before I start making release for the next video.